Now let's discuss troubleshooting a GRE tunnel. A GRE tunnel is a logical connection between a couple of routers that could physically be separated by multiple routers. And one of the cool things about a GRE tunnel, as opposed to something like IPsec as an example, GRE tunnels have the very unique ability to carry just about any layer 3 protocol you can imagine. Unicast IP, multicast IP, broadcast, IPX, AppleTalk if we wanted to do that. And we want to take a look at some common troubleshooting issues with GRE tunnels. One issue is we point to the remote IP address on this far end router, the packets get there, but they don't know how to come back. The routing table on the far end router needs to know how to get back to us. And our routing table, the source router, needs to know how to get to that destination. We've got to have our IP routing tables knowing how to get to one another. We could run into an issue called recursive routing. This is interesting. Recursive routing is you take a look at your IP routing table and you see what is the best path, what's the best route to get to this tunnel destination. You know what it is? The tunnel interface. The best way to form this tunnel is to go through the tunnel interface to get to that far end. That's not going to work very well. That can lead to some route flapping, and we want to avoid that. We can do that with a static route oftentimes. We might have the GRE traffic simply being denied by an access control list, or maybe we're not doing fragmentation correctly. We'll talk about those issues. Before we get into the specific troubleshooting aspects, though, let's take a look at a configuration of a GRE tunnel. Here's what we have. We have a virtual tunnel interface. And just like a physical interface would have an IP address, that tunnel interface has an IP address. We're probably going to want to set the MTU to about 1476 because I know normally a packet has an MTU size of 1500 bytes, but that header of the GRE packet, it's 24 bytes in size, and we generally want to reduce the IP packet's MTU down to 1476. And we want to do that all along the way from the source to the destination to avoid excessive fragmentation. We say, what's the source IP address of this tunnel? What's on our router that's going to be sourcing packets going down this tunnel? And where are we going? What's the IP address of the far end router? Let's go out to a live interface right now using this topology, and let's set up a GRE tunnel between R1 and R3. I've already got the configuration on R3. Let's do the configuration on R1. On R1, let's go into global configuration mode and let's create out of thin air a virtual tunnel interface. I'm going to say interface tunnel, and we can give it a locally significant number. I'll say it's 1, and I will assign it an IP address. I'll say IP address 192.168.1.1, and I'll give it a 24-bit subnet mask. Now, remember the tip we gave you about reducing the MTU size from the default of 1500 bytes to 1476 bytes to accommodate for the 24-byte GRE header? Let's do that. Let's say IP MTU 1476. Now, let's set up the tunnel source, an IP address on our router. I'm going to use my loopback interface of 1.1.1.1. I'll say the tunnel source is 1.1.1.1, and the tunnel destination, that's going to be the loopback IP address on router R3. It's going to be 3.3.3.3. And now the tunnel should come up. In fact, we see some feedback on screen. It just said that the tunnel 1 interface changed its state to up. Let's give a couple of verification commands to confirm this. Let's do show IP interface brief. Do I now have a tunnel 1 interface? I do. We see its IP address, and we see that it is in the up state. Fantastic. I'm curious, can I ping the far end of this tunnel? Let's try to do a ping to 192.168.1.2. Yes, I can ping the far end of the tunnel. That's good news. We could get a closer look at the tunnel by doing a show IP, or just a show interface rather, show interface tunnel 1, and we can see some additional information about the tunnel interface. Let's minimize our topology, get that out of the way a little bit. And we can see that the hardware is tunnel. It's a virtual tunnel interface. The encapsulation is tunnel, and we get to see IP address information and so forth. That is a look at how we can create a GRE tunnel interface. And we're going to have mirrored configurations on the routers at each end of this tunnel.